Hello everyone and welcome to lesson 10 of atomic structure. Miss Burker's here again and I'll be taking you through this lesson. So as every other lesson has started, I would like you to try this knowledge check. You should have your paper or your booklet handy there. So pause this video, answer these questions. So now I'd like you to switch to your other color of pen, whether that be green or red or whatever feedback color you have, and go through your answers with me to make sure that you have the right ones written down. So starting with the three subatomic particles, these are the electrons, the protons, and the neutrons. If you have them in a different order, that's fine, but you do need all three of those. The subatomic particles found in the nucleus are the protons and the neutrons. The subatomic particles we find in the energy levels are the ones that are left over, are the electrons. The overall charge of an atom, this is the important thing here, is that it is neutral or that it has no charge. The relationship between periods and energy levels, the period number is equal to the number of energy levels. So, for example, if an element is in period number 4, it will have 4 energy levels. If it's in period number 7, it will have 7 energy levels. Remember that energy levels can also be called shells. The relationship between the groups and the outer electrons, the group number tells us is equal to the number of electrons in the outer shell. Remember that the outer electrons can also be called the valence electrons, and we'll be using that word quite a lot this lesson, so I just wanted to remember that one. How to calculate the atomic mass, or the mass number of an atom. We have our number of protons plus the number of of neutrons. The atomic number is equal to the number of protons for the last one. So make sure you have all of those correct answers written in on your paper or in your booklet, wherever you're doing it, and then we'll move on to the lesson itself. All right, so we know that there are things in life that are not pure elements. Most of the things you react with on an everyday basis are not pure elements. You yourself are made up of atoms, but not a pure element. So in order for these elements to combine, they need to react. So first we're going to talk about why some atoms are unreactive. So why are some atoms unreactive? If they are unreactive, that means they won't react easily, and they are as pure elements. Because remember, when atoms react, they join up with other atoms. To form molecules. So, all atoms, apart from the noble gases, which you'll remember the noble gases are in group 0. If you remember as well, that is on the very right-hand side of the periodic table. of the periodic table, are reactive because their outer shell is incomplete. So do you remember what the other word is for the outer shell? Talked about it in the do now. It is the valence. Let's zoom in here a little bit so I can get it. Valence shell. So the outer shell is the valence shell. It is incomplete. It is not full of electrons. So it will have some electrons. It has some electrons. But it will have room for more than that. But it has extra room. So atoms don't like having that extra room in their outer shell, in their valence shell. So they'll react to try to get more electrons or to try to get rid of electrons so that they don't have that space in their outer shell. The noble gases in group 0 are unreactive and do not easily form molecules because they have stable arrangements of electrons. So they have a full outer shell. So when atoms have a full outer shell, they are stable. So it's like you when you have 2 feet on the floor versus only 1 foot on the floor. You'd rather have 2 feet if someone tackles you so that you are able to stay standing upright. So the noble gases have 8 electrons, except for one exception, which is helium, which has 2, but that is still a full outer shell for helium. So they have those 8 electrons, so they are stable. So another thing to keep in mind is the boiling points of the noble gases increase with increasing relative atomic mass. So as they go down the group, they become more, their boiling point increases. So they boil at a higher temperature. So I'd like you to pause this video for a minute, go in and look at this video about the noble gases, take some notes on that, and then come back to this one here. So now that you've had a good overview of the noble gases, those will likely pop up again at some point, but it's nice to have an introduction to them. So now we're going to go from those noble gases, which are unreactive, to all the other atoms, which are far more reactive than the noble gases. So we know that atoms want that full valence shell, that full outer shell. So they can exchange electrons with other types of atoms to try and fill up that outer shell so they can become stable. Because we know that a full outer shell means that they are stable. Whether that outer shell holds 2 electrons, 8 electrons, 8 electrons, or the 18 electrons of the 4th period, but we know that it needs to be full. So the electrons in the outer shell are called valence electrons, as we've said a couple times. So chlorine is in group 7 and has 7 valence electrons in its outer shell. So it has 7 electrons in its valence shell. So it has 7. Do you remember how many it needs in order to be full? Hint, chlorine is in period 3. So hopefully you've remembered that chlorine needs 8 electrons. This symbol here, E with a negative sign, is my symbol for electron. So needs 8 electrons to be full, to be stable. So full, we know that that outer shell being full means it is stable. So it will try to do whatever it can in order to get that outer shell to be full. So in chlorine's case, it has 7, it needs to get to 8. It has 2 options. It can either get rid of the 7 valence electrons it has in order to have the second shell be the full shell. So if we go in for a second, if I were to draw chlorine, so I'll draw it up here. So we have chlorine. Our first shell, we have 2 electrons. Our second shell, we have 8 electrons. And our third shell will have 7 electrons. So there's our chlorine atom. So in order to become full, in order to become stable, we need to either fill up this third shell, or we can completely empty the third shell, which will make the second shell, so this one here, become its full outer shell. Now we all know that 1 is a smaller number than 7, so it will try to gain that 1 electron. So it'll try to steal an electron from somewhere. So it has 8 electrons in its outer shell so that it will become stable. So we know that atoms are stable when they have a full shell by adding electrons or an empty shell by losing electrons. So they'll either empty their outer shell, so the second inner shell, so the next shell on the inside is the outer shell, or they'll gain electrons. So they'll do whichever option is easiest. And that easiest option is pretty well always which takes less electrons. So if it takes less electrons to lose, then it'll lose less electrons. If it takes more electrons, it'll gain more electrons. So if you look at our periodic table here, it goes by the groups. So for example, group 1, so if I draw lithium, for example, it is not in period 1, so it's in period 2, so we know it has 2 shells. So its inner shell must be full, and its second shell will have 1 electron. We know this because lithium is in group 1. So it's that 1 electron. Now lithium wants this shell, or wants its outer shell to be full. So it can either try to fill its second shell, or it can get rid of its second shell and make the first shell its outer shell. So for lithium to fill its second shell, it would need to gain 7 electrons, or it can lose 1 electron. So it's far easier for lithium to lose 1 electron than to try to gain 7, because 7 is bigger than 1. So it will try to lose that 1 electron. So lithium will turn into, to become stable, just like that. All right, if we go look at aluminum, so we have aluminum here. So it is in period 1, 2, 3. So we know it has 3 shells. And it is in group 3. So we know it'll have 3 electrons in its outside shell, and its inside shells will be full. So the first shell has 2, the second shell will have 8, and the third shell has those 3 electrons. So there we are. I can double check this because I know that an atom of aluminum will have 13 protons, so it'll have 13 electrons. So I can count them quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that all makes sense. So looking at aluminum, it is So it can either have this shell become full, or it can empty that shell and lose those electrons and let this one be its outer shell. So because this third shell needs 8 electrons and it has 3, it can either lose those 3 electrons or try to gain 5. Now, which one has a smaller number? It will lose the 3 electrons, and so it will lose that shell. So it'll say bye to that electron, bye to that one, and to that one. And so that outer shell is empty, so it just kind of disappears. And so it turns into that. However, this is now no longer an atom because it does not have the same number of protons as electrons, because we didn't do anything to the protons. Those protons are still all chilling in the middle, in the nucleus. They haven't gone anywhere. And we know that if we were to put in some extra protons or take out those protons, that it would change into a different element. If we were to add in a proton, it would turn into silicon. If we were to take out a proton, it would turn into magnesium. But we haven't changed the number of protons, so it still is aluminum, but we have changed the number of electrons. So this will come into importance later. What I'd like you to do on your paper now is to try to draw fluorine and try to figure out what would happen to fluorine if we did it the way we just did it with aluminum. So pause the video, give that a go. So for fluorine, we have in our nucleus, I'll do this in green so you know it's feedback. Fluorine, we have in our nucleus, we'll have those 9 protons and those 10 neutrons, because 19 take away 9 will be 10. So we know it's in period 2. So we know it has 2 shells. We know the first shell has to be full. And we know the second shell will have 7 electrons in it because it's in group 7. So 1, 2, 3, 4, 5, 6, 7. I can double check that by knowing an atom will have 9 protons, so 9 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So fluorine, that second shell, in order for that to be full, it needs 8 electrons in it. So it has 7, so it'll either gain 1 or lose 7. So we know it's easier to gain the 1 electron than to lose the 7. So fluorine will actually gain 1 more electron. You might have noticed that lithium wanted to lose 1, fluorine wanted to gain 1. So the only way fluorine can gain 1 is if it can take 1 from someone who wants to give it away, which is when the atoms react. If there's no lithium around or nothing to give it to fluorine, then fluorine will not be able to get that extra atom. If there's nowhere for lithium to give away its electron, then it will not be able to react. It'll stay as it is. So something I want you to notice is on the periodic table, hopefully you remember where that staircase is for the metals and the nonmetals. So you'll go under boron, between aluminum and silicon, and continue down just like this. With the metals being on this side and the non-metals being over here. So this comes into play as well when we talk about gaining and losing electrons. That the metals will all have 1, 2, 3, 4, so less than half of the electrons in their outer shell. So the metals will all give away electrons. So they will all lose the electrons. Whereas the nonmetals have the 7, 6, 5 electrons in their outer shell. So they are all closer to being full. So they will all gain electrons into their outer shell. Hopefully you remember what the charge of an electron is. I want you to think about it for a second. If you remembered that an electron is negative, well done. So this lithium, as an atom, so this one here is the atom, this lithium is neutral, right? Because it has an equal number of protons and electrons. This lithium has lost one of its electrons. So it still has 3 protons in its nucleus, but it only has 2 electrons. So if the electrons cancel each other out, so if this one and that one cancel out, that one and that one cancel out, it has 1 extra proton left over. So this lithium actually has what we call a positive charge. Whereas this fluorine, it will have, so our fluorine over here, it will have 9 protons because that hasn't changed. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's gained an extra electron, so it will have 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, if we start to cancel these out, that one, those two, going all the way down, we end up with an extra electron. And that electron has a negative charge, so this fluorine has a negative charge, -1 or just a negative. If it is more than 1, we would write 2, but if it's just the 1, we just can write the symbol. So it's no longer neutral, so we can no longer call it an atom. Now we need to call this one or this one, so this lithium or this fluorine, we need to call them ions. So an ion has a charge. It's gained or lost electrons, so it now has a charge. So now that's where we're looking back into here. So nonmetals are short of valence electrons. So they will try to gain electrons to fill up their outer shells to become stable. Because we know that's why every atom wants that full outer shell. They want it to become stable. So the nonmetals will gain electrons, whereas the metals will lose electrons. So when an atom has gained or lost electrons to have a full outer shell, it is then called an ion. And if they have gained electrons, they will become negative ions. So nonmetals become negative ions. Whereas metals will lose those electrons, so they will become positive ions. So make sure you have those notes because this is something that a lot of students mix up and it is something important to understand. So if they gain electrons, they become negative. If they lose electrons, they become positive ions. So metals become positive, nonmetals become negative. So to learn a little bit more about that, I would like you to pause this video and give this one a watch, and then we'll come back to this video here. So here there are 3 questions on this page, and on the next page in your booklet that your teacher sent through to you, there's 5 questions on the next one. So let's just check halfway through, check how you're doing. So I'd like you to go through, give them a go, and then we'll go over the answers in a moment. So hopefully you've written down the answers, so we'll go through them now. So the name of the elements in group 0 are noble gases. Why they are unreactive, because they have a full outer shell. Why atoms try and fill up their outer shells to become stable. The name of the electrons in the highest energy level are the valence electrons. How do metals get a full outer shell? They will lose electrons to get that full outer shell. Nonmetals will gain electrons to get their full outer shell. The name of an atom that has lost or gained electrons is an ion, and the charge of an electron is -1. If you struggled with that knowledge check, I would like you to go back and start the video from the beginning, making sure you're taking your notes, because everything in that knowledge check has been from this video so far. So this is a point to check, do I understand it? Yes or no? If you don't quite understand it yet, that's okay. Go back, rewatch the video, and hopefully you'll understand it better the second time around. So if you do feel good about that, we'll move on about the types of ions. So here we talk a little bit more about the charges on the ions. So when the metals lose their electrons, they form positive ions. We've talked about this already. When the nonmetal gain electrons, they form negative ions. So the nucleus, we know, has those positive protons and neutral neutrons. Atoms will have the same number of protons and electrons, so their overall charge is neutral. But we know in an ion, it's not the same number. But, so, the number of electrons lost or gained has the effect of the size of the positive or negative charge. So if it's lost 3 electrons, it will have a positive 3 charge, such as the aluminum. If it's gained 2 electrons, it will have a -2 charge, such as oxygen would have that. So now we're going to look a little bit more into that. So here's our example of sodium. So it has 11 protons. It's in group 1, so we know it has 1 valence electron. So because it has 1 valence electron, it will try to get rid of that electron. Once it's able to get rid of that electron, it will form a positive 1 ion. And because it's forming a positive 1 ion, we know it's a metal. So let's look and do magnesium together. So I'd like you to have this diagram drawn in your book. So with the circles just like this. So we know, so we can see here, magnesium has 12 protons. So an atom will have 12 electrons. So we know, starting from the beginning, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has so we've drawn our 12 electrons. So the number of valence electrons we have is 2. So we have those 2 valence electrons. Remember, the valence electrons are the ones in the outer shell. Well done. So because it has 2, 2 is less than 4. It's because it wants to fill it up to 8. So it's easier to lose those 2 than to gain the 6. So it will become a positive 2 ion. And because it's becoming a positive ion, we know it's a metal. Chlorine. So this is one we've done. So I'd like you to just pause the video and draw in just the electrons for chlorine itself. Noticing that it has 7 in its outer shell and it's in period 3. So because it's in period 3, we know it's 3 shells need to have electrons in it. So the first shell will have 2. The second shell will have 8. And because it's in group 7, it will have 7 electrons in its valence shell. So there is our electrons in chlorine. So it will try to gain 1 electron because it wants 8 in that outer shell in order to be full. It has 7, so it will gain 1, so it'll be -1. So we know it's a non-metal because it forms a negative ion. All right, now I want you to try that whole thing. Oh, we forgot to say the number of protons for chlorine. If you look at our periodic table, our number of protons for chlorine is 17. All right, so now for lithium, we have our number of protons. I'd like you to try this whole chart, or all 1, 2, 3 questions as well as drawing the atomic structure on your own. So pause the video, draw your electrons, and try to fill in those 3. We'll take them up in a second. So hopefully now you've unpaused the video. And so we have 3 protons, which means we have 3 electrons. So we have 2 in the first shell and then 1 in the second shell. So the second shell is its outermost shell because it's in period 2. So the number of valence electrons, we have 1 valence electron. So it will try to lose that 1 valence electron because it's easier to lose 1 than to gain 7. So we know it is a positive 1 ion. Because it's a positive 1 ion, we know it's a metal. So hopefully you have those answers in. So now I'd like you to give all of these 4 here a go. So we have fluorine, oxygen, potassium, and beryllium. Now, because I know not all of you have a periodic table in front of you, I will let you know the atomic number for each of these elements, and that should give you the number of protons, so you can put in the electrons as you need to. So fluorine has the atomic number of 9, oxygen has the atomic number of 8, potassium has the atomic number of 19, and beryllium has the atomic number of 4. So pause the video, draw your electrons for all 4, and then write the number of protons, the number of valence electrons, is it a positive or negative ion, and is it a metal or a non-metal. So hopefully you've had a chance to unpause the video and you have all of that finished. So let's have a look to see what the answers are. So for fluorine, we have 9, it's atomic number 9. So we have 9 protons, which means we have 9 electrons, which means we have 2 in the first shell and 7 in the outer shell. Oxygen, we have 8, which means we have 2 in the first shell and 6, 1, 2, 3, 4, 5, 6 in the second shell. Potassium, we have 19, so we start from the inner shell, not the outer shell. So we start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and you have 1 more. It can't go in the third shell because it's full with the 8. So 19 will go into the last shell, the valence shell. And for beryllium, an easy one, 4, we can fit 2 of those in the first shell, and the rest will go into the second shell. So now that we have our diagrams drawn, we need to talk about the number of protons. So fluorine, 9 protons, easy enough. Number of valence electrons, well, we can just count them. 1, 2, 3, 4, 5, 6, 7. So we have 7 valence electrons. We know it wants to have this shell to be full, and it needs 8. So it will gain 1 electron. So it will have a -1 charge. So that means it is a non-metal. Oxygen has 8 protons. It has 1, 2, 3, 4, 5, 6 valence electrons. It needs 1, 2 more, and 2 is less than 6. So it'll be a -2 ion, which means, again, it will be a non-metal. Potassium, it has 19 protons. It has 1 valence electron. And we know this outer shell needs 18 electrons. So it's way easier to lose the 1 than to try to gain an extra 17. So it will lose that electron and become +1 charge, which means it is a metal. And beryllium, it has 4 protons. It has 2 valence electrons, so it'll become a +2 ion when it loses those 2. It's easier to lose the 2 than to gain 6 more, and so it is a metal. So hopefully you have a good understanding about that. I want you to test yourself with these ones, looking to see argon and neon are noble metals. So will they have a positive or negative charge, will they form an ion? So give these ones a go. We'll take them up in a minute. The atomic numbers, so the atomic number for hydrogen is 1, atomic number for helium is 2, for neon is 10, and for argon is 18. So give those a go. Pause the video. We'll take it up in a minute. So hydrogen has 1 proton, which means it has 1 electron in its outer shell. So it has 1 valence electron. So is it a positive or a negative ion? You could have said either, because it can either gain 1 electron to have a full outer shell, or it could lose both the electrons and still have a stable shell. So if you said positive 1, that's fine. If you said negative 1, that's also fine. It does tend to form positive 1 ions. So I'd like you to correct that to positive 1 and just use that from now on. But if you said either 1, that is totally fine. And because it forms those positive, but it behaves more like a non-metal, which is why hydrogen is a bit of a weird one. So hydrogen is a non-metal, which is why we don't put it with lithium, but it does tend to form positive 1 ions. So helium, we have 2 protons, we have 2 electrons. Number of valence electrons, it's 2, but that outer shell is full. So will it gain or lose electrons in order to become stable? No, because it is already stable. So it'll not be an atom or an ion. So it will not be an ion. And it is a non-metal because of where it is on the periodic table. So argon, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That shell is full. 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 protons. We have 18 valence electrons. We have 8 valence electrons. So again, its outer shell is full. It's stable as it is. It doesn't need to gain or lose any, so it will not form an ion. And again, it is a non-metal because of where it is on the periodic table. Last but not least, neon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8. Again, it's not an ion and it's a non-metal. So here we have some more. This one we don't have to draw all the electrons, but it's still thinking about all of the different ones. So pause the video, copy down this chart. You can just do it all across. You don't have to do it in 3 different rows. So you can just put calcium here beside. So copy down the chart, and then I'll put up a periodic table for you to give it a go. Where things are. So there's your periodic table. Give those elements a go, and we will come back and have the answers. So starting with lithium. Lithium is in group 1. So it will have 1 valence electron, so it'll lose 1 electron, so it'll be a positive 1 ion. If you struggled with that, I want you, and you understand it now, pause the video, go back and fix some of the ones that you have made a mistake on. That's totally all right, and it will help check yourself that you are learning, because that's what this is all about. It's about the learning process and not anything else. So magnesium is in group 2. It has 2 valence electrons, so it will lose those electrons to become a positive 2 ion. Beryllium is also in group 2. It will lose, so it has 2 valence electrons. It'll also lose those electrons to become a positive 2 ion. Calcium is in group 2. It has 2 valence electrons. It will lose those 2 to become a positive 2 ion. You're probably seeing the trend here. Potassium is in group 1. It has 1, so it'll lose that electron to become a positive 1 ion. Chlorine Here's a different one. It is in group 7. So it has 7 electrons in its valence shell. So it will gain 1 electron. So it will become a -1 ion. Fluorine is again in group 7. So it has 7 valence electrons. So it will again gain 1 electron. So it will become a -1 ion. Nitrogen is in group 5, so it will have 5 valence electron, so it will gain 3 electrons in order to get up to that magic number of 8. Well done. So it'll have a -3 charge. It's weird. I know it feels weird that it's gaining electrons and it becomes negative, but remember that that electron has that negative charge. So if you get more negative, the negative number will increase. It feels weird, I know, but that's just the way it works. Oxygen is in group number 6, so it has 6 valence electrons. It'll gain 2 of those electrons, so it'll be a -2 ion. Hydrogen is in group number, it doesn't really have a group number, it's kind of on its own. So it's valence electrons, we know, however, it does have a valence electron of 1. So it will lose that 1 electron to become a +1 ion. And helium is in group 0, which doesn't mean it has 0 electrons in its outer shell. It only has 2. So it will not gain or lose any electrons. So it will have a neutral charge, or it will not form an ion. So here's something to think about, and this is a bit of a stretch and a bit of a challenge, but magnesium in group 2 and bromine in group 7 form an ionic compound. So what do you think happens to the electrons in magnesium compared to the electrons in bromine? Think about what they want to do and think about how you think they might work together to deal with their electrons. So try to maybe draw a picture or see or write about what would happen, and we'll talk about it in a minute. So hopefully you've seen that magnesium is in group 2. So I have a magnesium atom, and it will have 2 electrons in the outer shell. I'm only drawing the outer shell just to keep it simple here. And bromine is in group 7, so it will have 7 electrons in its outer shell. So you've probably seen that magnesium wants to get rid of these 2 electrons. And bromine has a nice empty hole here for that electron to take those electrons. So magnesium will give 1 of its electrons to bromine so that this bromine is now happy and content and stable with its full outer shell. Magnesium, however, still has 1 more electron to get rid of, so it will meet up with another bromine atom with, again, its 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell, and it will give that electron to a different bromine atom. So for every 1 magnesium atom, we need 2 bromine atoms, but magnesium will be able to give away its electrons to the bromine atoms. So this will turn into, we'll have 1 magnesium ion with a +2 charge because it's given away 2 of its electrons with its full outer shell, because its second shell will become full. And we'll have 2 bromine ions with a -1 charge because it's gained 1 electron each. So we have that one. Actually, I'll draw it like this. I'll draw out the second one just so it's easy to see. bromine. So you will learn more about this type of arrangements in future lessons, but this is what is happening. And this is what we call an ionic bond, because this positive ion and this negative ion will be attracted to each other through the electrostatic force. But as I said, we'll talk more about that in future lessons. So now to finish up this lesson, here are 9 questions. Give this knowledge and application check a try, writing down your answers. We'll take them up in a minute. So hopefully you have those answers written in. So the name of the electrons in the outer shell are the valence electrons. The charge of the electrons is -1. The subatomic particles that remain constant at an atom are the protons, because the number of protons doesn't change. Why some atoms are unstable, because they do not have a full outer shell or a full valence shell. The group of atoms that are stable are group 0, or the noble gases. We know that metals form positive ions. We know nonmetals form negative ions. The way I remember this is nonmetals and negative both starts with the same letter. So the overall charge of an atom we know is neutral, or it has no charge. And why do they gain or lose electrons? To become stable. Now, hopefully you feel good and you understand that all well. If you, however, are still struggling with it, email your teacher and they will be able to give you some extra help or some extra videos or something to go in and see. You can always go back and re-watch parts of this video if you feel like you need to. But now go and try the Educate quiz that your teacher has posted, or any other thing that your teacher has posted for you to do.